Hello everyone, this is for the homework for, as you can read, the intro to derivative applications. The two things you've been doing with derivatives is, first off, you take the derivative, heck of an x, and set it equal to 0. That's going to find your minimum or the maximum for the problem. The other thing you've been doing is finding the derivative, and then taking that derivative and evaluating the derivative at a specific value, and that's going to return the slope at a certain point. In this one, you were asking, where is the slope 0? Here you're asking, okay, given a certain value of x, put it in and tell me what the slope is at that coordinate. So there's two choices for this whole assignment. You're either going to set the derivative equal to 0, or you're going to evaluate it at a certain value. Okay, so here goes. Find the slope of the tangent line. Okay, so here you're going to find the derivative. You're going to find c prime, some value. Then you're going to take the -3 and fill it in for the x value in the problem. Whatever the derivative is, you're going to evaluate it at -3. And in case you're a little unsure, finding the derivative is you're going to take the limit as h goes to 0 of f of x plus h minus f of x over h. And in the interest of time, I'm not going to find the derivative for this. Okay, that's something we've been practicing and you guys should know how to do. For this one, you're given a position equation. Find the instantaneous velocity. This is analogous to finding the slope. So the reason I'm giving you this is so you can be used to different wording. Okay, so you're going to find the derivative for s, and then evaluate that derivative at 3. And that will tell you, in this case, the velocity at when time is 3 seconds. Okay, assuming it's seconds, it could be minutes, but usually it's seconds. Okay, so find the derivative, evaluate the derivative. So going back to what I was saying up here, oh, I guess I erased it. Your two choices were find the derivative, set it equal to 0, that found min-max. Your second choice was find the derivative and evaluate that derivative at some number. Right? A ball is thrown upwards with initial velocity at 32 feet per second. That's this 32 that's right here. So you don't have to do anything with it, and they're just saying it's part of the wording that I'm trying to get you guys used to. Same thing with 0 feet. So really what this is s of t is equal to -16x. Oops, those should be t's. Oops. Or they should all be x's. I'm looking at the wrong spot. There's a eraser. Okay. It should be, let me pen again, -16t squared plus 32t. That's what it should be. If I have a t there, I should have a t there. So sorry for the typo. I apologize. With an initial starting height of 0. That's the 0 that's at the end here. That's why it's not there. So again, you don't have to do anything with the 0. If they said the starting height was 12 feet, you put a 12 here. But again, they're giving it to you. It's nothing you need to do with it. It's just right now about getting you used to the wording. Going back to your two choices, you either set the derivative equal to 0 or you evaluate it at some number. Here, find the maximum height. So that's back to those two choices up above. It turns out that what you need to do is take the derivative and set it equal to 0. And it will return a time value when the ball reaches its maximum height. Okay, again, I think finding the derivative is something you guys can do. You just need some help with the wording and what it wants. So before I flip to the next page, this finds mins and maxes. Whoops, forgot the A. Mins and maxes. This evaluates and tells you what the slope is at a specific number. It's a slope for that value that you're filling in. Right? Okay, so this is where the wording gets a little bit different. You've got some fencing. Your total fencing is 32 feet. You want to create the biggest or your maximum grazing area for your cattle. Maximum area. Okay? So maximum means you're going to take the derivative and set it equal to 0. Okay? So what are you going to set equal to 0? What equation you got to work with? Well, It's talking about area. You know the area, and you're going to assume the thing is, rectangular in shape, is length times width. So let's say I say these sides are x, these sides are your L. Right now, what you'd have is area is equal to x times L. I can't have a formula with two variables in it and take the derivative. You guys don't know how to do that yet. So what I need to do is get rid of the L. Well, all of these pieces added together need to equal 32. So in other words, I'm looking at the perimeter. Perimeter in this case would be 2x plus 2L. The perimeter is 32 feet. I need to solve for L and replace L with what it's worth. It's a 2. So I'm going to subtract the 2x, so 32 minus 2x is equal to 2L. Divide by 2, and I get 16 minus x is equal to L. Now replace this with what it's worth. And you have your area is equal to 16x minus x squared. This is what you need to take the derivative of. So how about I wrote it a of x is equal to 16x minus x squared. You want to find a prime, the first derivative. Then set that equal to 0, and that's going to solve for the value of x, the size of x, that will make the biggest area. Okay? So what I did again was I established the perimeter by letting one of the sides be x, filled in the amount of fencing that they told you, right here, and then I solved for L so I could replace it in the formula for area, which was just length times width. One of the sides was x, one of the sides was L. Replaced L with what it's worth, multiplied it together, and now I need to take the derivative of it and set that answer equal to 0 and solve for x. Okay. Another type of problem relating to this fencing that you're going to have in your homework is they're going to say, how about we have the same 32 feet to work with, but this time I want to divide it into, say, how about 3 equal grazing areas? Not very equal looking, but there you go. That it's still 32 feet of fencing, so I have to have the perimeter and these two pieces. So if I let that be x, I know that amount of fencing is also x, that amount is also x, as well as that side. This side is still L. So you'd have 30, well, let me just back up. Perimeter is equal to 1, 2, 3, 4 x's plus 2 L's. And your perimeter, if I just left this number alone, is still 32 feet. Now I need to solve for L. So I'm going to subtract the 4x. Sorry, I did lowercase on that one, I don't know why. Then I need to divide it all by 2. So I'd have 16 minus 2x is equal to L. Then go back, area is length times width. Area is your length, which is 16 minus 2x, times your width, which is x. So area is equal to 16x minus 2x squared. Take the derivative of this and set the derivative equal to 0. And that will give you the value of x. Once you solve for the value of x, you can come back and fill it in to find your length. All right? Now, this would be by far the hardest one on here. So here we go. I'm trying to visualize this. You've got the point 60, which is hanging out over here somewhere, and the line y is equal to minus 3x plus 0. The y-intercept is 0, and the slope is negative 3. So your line's coming through something like this. What you're looking for is what is the minimum distance, what is the coordinate, sorry, you're not looking for the distance. You're looking for what is the coordinate on this line that would create the closest point to that point. Okay? You're looking to find this coordinate. Your answer is going to be in xy. You're looking for a coordinate. And you're looking to minimize this distance. I hope that you can see the farther out I get on this line, the bigger that distance is going to be. So somewhere in here is going to be the closest point to that line. So the closest would be a minimum. So that means whatever equation I'm going to work with, I take the derivative and set that derivative equal to 0. Because setting it equal to 0 finds the minimum value of x. It minimizes it, or it could be a maximum. Okay? But as you've seen, there is no maximum, because as you move farther and farther and farther around this line, the distance increases. So there wouldn't be a maximal distance. Okay? The maximum distance is going to be infinity. But there would be a closest point, a minimum point. Okay? Now, what you're going to use is the distance formula. It's really a modified Pythagorean theorem. In one of them goes the x's, and in one of them goes the y's. We've got one coordinate, and what we're looking for is an xy value for the other coordinate. Now, if you know an x value on that line, what do you do to find the y value? You fill it back in the equation. So the y value would be negative 3x. Okay? So I've got 6, 0, and x, negative 3x. Those are the values I need to fill into this. So let's start setting it up. So I'm going to fill the x values in one and the y values in the other. So it's going to be x, 6, and now negative 3x and 0. I need to expand that. So I've got x squared minus 12x plus 36. And then that's going to be plus 9x squared. So then I've got 10x squared minus 12x plus 36. Okay, now that's your distance. This, I need to find the derivative and set that answer equal to 0. And that's the hard part. So to remind you guys how you do something with the square root and take the derivative, let's just keep it real simple. Let's say I've got that. And I need to fill out this. And take the limit as h goes to 0. So, first thing you do, x plus h minus f of x, which is square root of x, over h, and then take the limit. But as you guys can remember, taking the limit right here is going to give you 0 over 0, so it doesn't tell you anything. And what you guys ended up having to do was multiply by the conjugate of the numerator. And the conjugate would be x plus h plus the square root of x over the same thing. This created the difference of square pattern. So the end result of the difference of square pattern is you square the first thing minus square the second. Square the second thing. I don't want paint, I want eraser. Square the second thing over h times your conjugate. X's cancel out. The h's reduce. So you have 1 over the conjugate, and then you take the limit. So that would be 1 over square root of x plus h plus the square root of x, and you're taking the limit as h goes to 0. So that h goes to 0, and you have 1 over the square root of x plus the square root of x, so you have 1 over 2 square roots of x. Then you set that equal to 0, because that would be the derivative. Okay? So here, this is the hard part. Filling this sucker out. Here goes. Okay. Take a deep breath, because this is going to take a little bit. Alright, here we go. So I need to find f of x plus h. So you've got the square root, and you got 10 x plus h squared minus 12 x plus h plus 36. Then I subtract the original function, which is this thing, 10x squared minus 12x plus 36, and it's all over h. Now, just like here, I need to multiply by the conjugate. All right, to save space, I'm hoping you guys are okay that all that makes the conjugate is I'm changing this sign to a plus. So, in the interest of space on here, I'm going to write c over c multiplied by the conjugate top and bottom. And you know that when you multiply by the conjugate, the short answer is you just square this thing and write it down. So I'm going to square this thing, and I got 10 x plus h squared minus 12x minus 12h plus 36. I need to expand that. Remember, that's x squared plus 2xh plus h squared. So we got 10x squared plus 20xh plus 10h squared minus 12x minus, oops, I had a mistake. Why did you guys speak up? Okay, mistake's right here. That's an h. Right there, an h. Minus 12h plus 36 minus, you square this thing, so it's going to subtract everything there. Minus 10x squared plus 12x minus 36. It's all over h and the conjugate. But before I write that, I'm going to get rid of stuff that cancels out. Right there, and 36 and 36. So I've got 20xh plus 10h squared minus 12h over h times, I'm still going to write c for conjugate because I don't need it right now. Okay, it's not something I need to evaluate right now. I'm not taking the limit, so I'm just going to let it be c in the interest of making stuff a little cleaner. There's an h that will cancel out on this. So I've got 20x plus 10h minus 12 over, now there's the conjugate, which was the square root plus a square root. And in that square root, to go back up and remind you what's there, I'm just going to write the shortened version here rather than the expanded out version. So this and this. Okay? So we had 10x plus h squared minus 12x plus h plus 36. And this was 10x squared minus 12x plus 36. Now, take the limit as h goes to 0. So this is going to go away, that h will go away, that h will go away. And what you're left with is 20x minus 12 over the square root plus the square root. And they're identical. They're both the same. So this would become 20x minus 12. Look right here. I had the same square roots, so I had two of those square roots. 2 of the square roots, 10x squared minus 12x plus 36. This 2 is a product, so I can reduce it here. So that becomes 10x minus 6 over the square root 10x squared minus 12x plus 36. Okay? Now, going back up, so that's the derivative. So that would be d prime of x. That's the derivative of the distance. Okay, that's the derivative of this thing. Okay, right here. It's a derivative of that. Okay, and what we said was we need to find the closest point. We need to find the minimum. So you take the derivative and you set it equal to 0. That's the derivative. I'm going to set it equal to 0. So let me, just to clean stuff up, a little less writing. I'm going to set it equal to 0. And if it helps you see it, write 0 over 1, no cross multiply. And you get 0 equals 10x minus 6. Add the 6, divide by 10. So x is equal to 3/5. Okay? Now, go back up and remind yourself what you're looking for. You're looking for a coordinate that is closest to this point. You're looking for a coordinate, and the coordinate was found by your x value, which you found is 3/5, and then negative 3 times that x value. Negative 3 times that would be negative 9/5. That's the coordinate that's closest to this point. So again, what you did, just going back, you had a coordinate they told you, you had a line that they told you, and you wrote that coordinate as your x value, and then your y value is worth whatever that equation is. This is the point they told you. You fill those into this distance formula here and gave you this. You expanded it, collected like terms, And that gave you the distance equation for that. That would give you the distance. To minimize this, you had to take the derivative. And that's everything that followed. And you multiplied by the conjugate, collected stuff, simplified stuff, and then that returned the derivative. Oops, I'm not far enough down. I'm not far enough down, which was this right here. This was your derivative, d prime of x. Then you set that equal to 0 by cross-multiplying, and then you solve it. Okay? So that's walking you through what your homework assignment will be for tonight.